Hello.
Uh, Good morning, sir.
I have to go to office for there is something. Okay, so I'll take 5 6 minutes. Okay, can I come from office for few?
Yes, sir. Sure, sir. Sure, sir. We will be there, sir.
Yeah, just wait. Okay, I have to go. Admin, who is this admin and Metcom? Hello.
Yes, sir. Yes.
No, who is this admin and Metcom? Admin, who is this? Hello.
Sir,
Yes, sir.
don't know. Admin, I sure.
No, who is this admin?
Sir, I think it's showing my account. I don't
Sorry,
know. Sir, it's showing my Saurabh.
it's
Saurabh.
showed out.
But I don't know, sir, why it's showing admin. I joined with my account, sir, but it's showing admin.
Okay.
Okay, sir, I am joining with my college account.
So we'll start this martingale theory. Yeah. So yeah, so this thing, I mean, what you call martingale theory is something is important in the financial mathematics and usually in the stochastic process is a very important thing. So yeah, we will try to do this martingale and Markov chain. These two we have to do. Um, yeah, let me join. Am I audible?
Yes, sir.
Okay. So let's start. So today is so we'll do martingales. So we'll do the martingales, but we'll do it in discrete time. Okay. So, mm, so martingales, from the fact that it also comes from, I mean, this is one of the main thing from conditional expectation. Okay. So martingales is also one of the, I mean, you say the application or whatever is uh, conditional expectation. So application or it's a use of conditional expectation. So of course, martingale you have discrete time as well as continuous time. But if this course is mainly we are dealing with the discrete things, so we'll do the doing the discrete time martingales and continuous is also almost the everything every property or almost of everything will go through there. I mean it's nothing extraordinary or anything. And I mean the so like discrete random variable, continuous random variable. Similarly, you have uh, everything. I mean, like Markov chain also you have discrete time, you have continuous time. So this is also martingales in discrete time and continuous time. These things are there. Okay. So yeah. So so let's start with some basic definitions. Okay. So. Uh, So basically, this is actually you will see the sequence of events. I mean, we will study certain properties of a sequence of events. Okay, so so in a sense that so for example, for fixed small omega belongs to omega. Okay. If you see the sequence of random variables, x1 omega, x2 omega, like this. Okay. Uh, uh, so so this is the sequence of uh, so this is so this is a these are numbers over the real line, right? So because yeah, any random variable is a map from omega to r, right? So or you can also say hmm, real value random variables, right? This is called uh, sample path. Mhm. So for fixed omega, you see the this was so in a sense that for for it means for fixed small omega belongs to capital omega, you see that xi of omega. This is a sequence of these things for I belongs to a natural number. Okay. Okay. So this is a sequence of real numbers, so sequence of values. So so this is called the sample path. So you need these things and and also there is also another important concept of mm, uh, it's called a filtration. Okay, so definition. So so what is the filtration? So a sequence of sigma algebras or fields, sigma algebras or fields, whatever. So, so so this is a sequence of so this is called uh, filtration. It's called filtration. So so sequence of sigma algebra, which is a subset of omega f. So you have a probability space. You have a overall probability space like uh, omega f t, right? You have a probability space t, and you consider a sequence of sigma algebras. Okay. So so in a sense that so what is this Fn? So this so basically this Fn, right? This represents our knowledge at time n. So in a sense that you so in a sense that so in a sense that in a F1 is the you have the information till time one, right? I mean, we have done what is X is measurable with respect to a sigma algebra F. What is if a random variable is F measurable, right? Now I am giving you the more information or I am adding time, some sort of time component with it. Okay, so uh, in a sense you have so in a sense that so so in a, so x1, so here it is like x1 is f1 measurable, x2 is f2 measurable, in a sense that xn is fn measurable. Okay, so you want to get all the information about certain things, right? Suppose you want to decide over some price of a stock over certain days, right? Now, what you look at you want to get some idea about how the stock behaves in certain day, correct? And you want to invest there or you don't want to invest there, correct? Now, how will you make your decision? How will you make your decision? You need certain information about the stock, how it behaves before nth day, right? Suppose you are seeing you are seeing a stock today, and you want to see whether you want to invest in the stock or you don't want to invest in the stock. So your decision of investing in the stock today will come from studying about the stock from suppose last 10 days, correct? You want to see whether the stock in last 10 days, whether what is it is behaving good, is it giving some profit or is it giving some loss? If it is a bad stock, if it is giving no profit for last 10 days or something, last 1 month, you definitely not going to invest there, right? You will going to invest in some stock which is showing sorry. Yeah. Yeah. So can you see my this thing? My no.
Yes, sir.
Okay. Oh, sorry. So you want to invest. So you want to. You definitely want to invest in some stock or share which is giving a little bit profit from the last few days, right? Or last few days or last month or something, right? So in a sense that this F. So you want those informations, correct? So Fi, in a sense, this is the filtration is increasing with time. So F1 contained in F2, contained in F3, contained in the overall over F. So for so Fn, so this Fn contains all the information from first day to nth day, right? Correct. So it contains. So in a sense that Fn gives you the information about certain because what is a sigma algebra? It's a collection of events, right? It's a collection of events. So something has occurred or something has not occurred. That information so whether the profit is there or not there, you will get from this sigma algebra. So in a sense that nth day contains all the information from the first day, and n plus 1th day will contain all the information till n plus 1th day, right? So in a sense that you have therefore uh, so whether something happened till nth day, I mean, so some events is there in till nth day, you get there those information from the sigma algebra, right? Okay, and so So let's consider some example. Okay, how it was. Example. Okay. So we consider a sequence of coin toss. Okay, the first this thing and this, and uh, uh, and so you have a first coin toss, second coin toss, third coin toss, like this. So you have a sequence of coin toss. Okay. And here you consider the sigma algebra Fn. Okay, so what is this? It is sigma algebra generated by till x. Okay. So we have done these things, that what is sigma algebra generated by sequence of random variables and these things. Correct. Okay. So uh, so Fn is the sigma algebra generated by all the coin tosses. So till nth coin toss. Okay. Now you consider an event. Okay. Consider an event. Okay. So the event is A. Okay. So we consider an event that at least the first 5 tosses produce at least 2 hits. So this is my event. I want to see about this event. So, so what we have is n equal to 5, correct? N equal to 5. So in a sense that you toss a coin 5 times, right? So, 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 so in a sense that toss a coin 5 times and you decide when you decide uh, whether A has offer or not. Okay. So now suppose I have mm, uh, consider suppose I have the first mm, suppose first 4 outcomes till head, right? Uh, till till. I have these 4 outcomes. Till head till. Okay. Now suppose if you have this thing, till head till. Um, I have tossed 4 times. Okay, so I have to toss 5 times. So for mm, so I so in a sense that so what is my event A? Event A is the first 5 coin tosses given at least 2 heads. Okay. Now from here we cannot say whether A happened or not because I have tossed only 4 times, right? To get A, so I need another head, and also I have another toss remain, correct? So, uh, so if I have, so I have one toss remain, and I have I did still, so I can get a head, and but A is not still not there. Whatever the A is there, so in a sense that here A is not an element of F4, right? A is not an element of F4. I mean, it can be element of F5, but if I have this outcome of the experiment, I am tossing the coin and getting these things, then I cannot say that A is in F4. I mean, it may happen in F5, right? So okay. But suppose my experiment comes like this: H T T, right? Or for first four tosses, or T H T H. It can come anything. I mean, you can have uh, H T T H, whatever. But here you see this A happened because your A is the first 5 point tosses given at least 2 head you will get. So in the fourth time only F4. So here A belongs to F4, right? In this all examples, because you get your 2 tosses, 2 heads, right? I mean, or better to say, I mean, I can say like this that um, so in a sense that okay, just explain me anything. So here you got 2 head, that is okay, that is clear, there is no problem. Uh, but mm, I mean, my A, the way I define my A is a sense that the first 5 point tosses give at least 2 heads. So in a sense that I need to do the fifth time. I mean, I need to do the fifth time. I mean, fifth time I have to toss the coin. Okay. Uh, um, I have to toss the coin. Then only I can say whether A is in F5 or A is not in F5. Because my point is that I have defined A in that way that you coin toss 5 times and you get at least 2 heads. I mean, though in a prima facie it looks like that here you have the things, you got the things, but that is not your complete A, because your A says that you toss the coin 5 times and then given at least 2 heads. So in a sense that you have to coin A means you have to toss the coin 5 times, and you see those events where it is two times you get. You get and so So in a sense, this is important, or I can say this filtration, okay, usually contain the knowledge or information. Information hmm, accumulated by observing outcomes of the uh, random. In a sense that so 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 that's what FN represents our knowledge at times. So in a sense that uh, and so this one also FN we have defined sigma algebra generated by x1 to xn. So so in a sense FN, right, contains all information contains all information. FN contains all informations about x1, x2, whatever it is. So yeah, we can write one definition when it says the definition. You say that a sequence of random variables x1, x2, dot 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 dot, right, is adapted is adapted is adapted to a filtration. F1, F2, if Xn is Fn measurable for each n 1, 2. So this is the definition of adaptedness. So I mean, see, Xi is Fi adapted. Okay, so so Xn is Fn measurable. Okay. Okay. So in a sense that X1 is F1 measurable, X2 is F2 measurable, but F2 has all the information X1 and X2. X3 has all F3 has the information about X1, X2, X3. So X1 you can say X1 is Fi measurable for any I greater than equal to 1. Right? I mean, because Fi contain all the information from 1 to x1 to xi, right? So this is the adaptedness. Okay? Adapted xi is fi adapt. So we'll discuss about these things later. Okay. The next class. But martingale is a very important concept. Okay. Thank you. Okay.
Thank you, sir.
Thank you, sir.